Well, hello, everyone. It's good to have this opportunity to share with you some recent information about the health effects of soy foods. It's unfortunate that we are not able to be together, but I hope you find this presentation informative nonetheless. I'm going to be speaking about 4 topics today: cognitive function, skin health, liver fat, and I'll briefly talk about the protein leverage hypothesis. Now, I'm going to be spending most of my time talking about the first 2 topics, and because these topics involve soy isoflavones, I thought it'd be appropriate to provide a little background information about isoflavones, although I'm confident that many of you are familiar with this information, so I'll be rather brief. I actually entered this field about 30 years ago because of my interest in isoflavones and my belief that they provided a variety of different health benefits. And if you're interested in isoflavones, you're going to be interested in soybeans and soy foods because among commonly consumed foods, soybeans are uniquely rich sources. And you can see this point illustrated on this next slide, where the average per capita intake in Japan among older individuals is about 30 to 50 milligrams per day. In contrast, in the US and in Europe, it's fewer than 3 milligrams per day. There are about 25 milligrams of isoflavones in a serving of a traditional soy food, such as a cup of soy milk or a half a cup of tofu. And you can come up with a pretty good estimate of the isoflavone content of a traditional soy food if you know the protein content of that food, because there are about 3.5 milligrams of isoflavones per gram of protein. Here we see the 3 isoflavones in soybeans. The predominant isoflavone is genistein, and it's the isoflavone that is thought to be most biologically active. On the right-hand part of the slide, you can see that the structure of isoflavones is fairly similar to the structure of 17-beta estradiol, estrogen, the female reproductive hormone. And because of the similarity in chemical structures, isoflavones are able to bind to estrogen receptors and to exert estrogen-like effects under certain experimental conditions. And for that reason, they are commonly referred to as phytoestrogens or plant estrogens. However, although they are classified as phytoestrogens, the isoflavones are very different from the hormone estrogen. And in fact, sometimes they have effects opposite to those of estrogen. And that's an easy concept to understand when you consider the case of cholesterol and phytosterols. Now, these 2 molecules are much more similar in chemical structure than our isoflavones and estrogen, and yet they actually have opposite physiological effects. Large amounts of dietary cholesterol will modestly increase blood cholesterol levels, whereas a couple of grams of phytosterols every day will lower blood cholesterol by as much as 10%. So you can see that small differences in chemical structure can result in large differences in physiological effects. And in fact, in addition to having effects opposite to those of estrogen, in some cases, in some tissues, isoflavones aren't going to have any effects at all, even though those tissues are affected by the hormone estrogen. And isoflavones may also have effects independent of their interaction with estrogen receptors. However, these estrogen-independent effects have been observed mostly in vitro and animal studies. So to summarize, isoflavones and estrogen have a similar chemical structure, but they differ at the molecular and at the clinical level. At the molecular level, isoflavones preferentially bind to and activate estrogen receptor beta in comparison with estrogen receptor alpha. And I'm going to come back to this point a little bit later on during the presentation. Now let's talk about cognitive function, which of course refers to mental abilities, learning, thinking, reasoning, remembering, problem solving, decision making, and attention. Cognitive function can deteriorate to the point where a condition referred to as dementia develops, which affects memory, thinking, orientation, learning capacity, language, and judgment. Now, unfortunately, It's estimated that about 50 million people throughout the world suffer from dementia. And it's important to emphasize that dementia is not a normal part of aging. Dementia is a major cause of disability and dependency among older people worldwide. And it not only adversely impacts the individual with dementia, but also, of course, affects the caregiver and society at large from both a health and an economic perspective. I just want to emphasize the current prevalence of about 50 million people worldwide, because projections are that over the next 30 years or so, the number of people with dementia is expected to increase 2 to 3-fold, and most of that increase is going to occur in low and middle income countries. There have actually been more than 100 studies that have evaluated the effects of soy and isoflavones on brain function. Now, many of those studies are animal studies, but there also have been quite a few observational and clinical studies as well. Now, in 2014, Sony and colleagues published a very nice comprehensive review that concluded as follows: the evidence to date is not sufficient to make recommendations about the association between dietary intake of soy isoflavones and cognition in older adults. In other words, the data weren't indicating that soy enhanced cognitive function or impaired cognitive function. And I was very content to accept that recommendation and to move on to focusing on other areas related to soy that offered more promise. However, subsequent to the publication of this analysis, several studies were published that made me think soy, in fact, may improve cognitive function. One of those studies was a 2018 publication from Taiwanese investigators, which found that soy-based foods were negatively associated with cognitive function decline among Taiwanese elderly. In other words, the greater the soy consumption, the less likely it was for an individual to suffer from cognitive decline. So let's take a brief look at this study. It involved over 1,000 men and women over the age of 65, so older individuals. The men and women divided into 3 categories according to the amount of soy they consumed: no soy, less than 1 serving per day, and at least 1 serving per day. So there was a nice range of intake among this cohort. And we'll see next the adjusted odds ratio. So the odds ratio were adjusted for multiple potentially confounding variables. And here we see quite clearly, as soy intake increased, risk of cognitive impairment decreased. In fact, risk was decreased by more than 50%, and that finding was very statistically significant. Now, before moving on to the clinical trials, I do want to mention a word or two about the relationship between dietary fat and cognitive function. This is a very, very intriguing area. And again, there's some research suggesting that soy foods may be beneficial because of their fatty acid content. Here we have a systematic review and meta-analysis that was published last year involving 9 studies and 23,000 participants. So it was quite a large database. The results showed that compared with the lowest category of consumption, the highest category of saturated fat intake was associated with an increased risk of cognitive impairment, about a 40% increased risk, and a nearly 2-fold increased risk of developing Alzheimer's disease. Both of these findings were statistically significant. In contrast to saturated fat, unsaturated fat intake was unrelated to risk. And of course, as I'm sure most of you recognize, soybean oil and the fat in soy foods and in soybeans is predominantly unsaturated fat. Almost 90% of the fat in soybean oil is unsaturated. So if you replace foods high in saturated fat with soy foods, you may end up decreasing your risk of cognitive function. Now, of course, if we're going to make any definitive or meaningful conclusions about the relationship between soy and cognitive function, or any outcome for that matter, we really have to base our conclusions on the clinical trial data and also systematic reviews and meta-analyses of the clinical data. The first meta-analysis that I'm aware of that was published or that examined the effects of soy on cognitive function, was published in 2015, involved 10 trials, 1,000 postmenopausal women. Trials last 6 to 30 weeks in duration. The meta-analysis found that soy isoflavone supplementation seems to have a positive effect on improving summary cognitive function and visual memory in postmenopausal women. 1 year later, an Australian trial was published that found there was evidence of improvement in reaction time and reasoning speed in response to soy protein isolate. Soy protein isolate is about 90% soy protein. Reasoning speed refers to the ability to make reasoned decisions concerning distal relationships between stimuli. And reaction time is the speed at which one can respond using a computer keyboard to changes displayed on the monitor. This is a very well done study, 46 men and women between the ages of 45 and 75. The study utilized a crossover design, 8 weeks per treatment. So half of the subjects consumed soy protein, 50 grams per day for 8 weeks, half whey protein. There was then a washout period, and the participants consumed for another 8 weeks the opposite protein. And here we have the results sub-analyzed according to gender. The higher the change means there was an improvement. Now, interestingly, what we see is that there's no difference between whey and soy among men, but among women, there was actually a decrease in response to whey protein consumption, whereas it was a statistically significant increase in response to soy. So an improvement in reasoning speed. We see a similar situation with reaction time. No difference among men between whey and soy. However, among women, a small decrease, impairment in change in reaction time among those who were consuming whey or when they were consuming whey. In contrast, when soy was consumed, there was an improvement in reaction time. Now, I don't want to give the impression that soy doesn't improve cognitive function in men, because here we have a 2009 study that found isoflavone supplementation in healthy males may enhance cognitive function. This study was quite small, 34 men, average age 49 years. Again, a crossover design, 6 weeks per treatment, used a much larger dose of isoflavones than in the previous study, 116 milligrams per day versus placebo. That's about 4 or 5 servings of soy, so that's a very high end of the dietary range. And then finally, we have what I consider to be the most definitive data, a meta-analysis published earlier this year. It involves 16 randomized clinical trials, almost 1,400 participants. Now, as you can see quite clearly, most of the participants were postmenopausal women, which is not surprising, but there were 107 men in this meta-analysis. The mean age was 60 years. The meta-analysis found that there was support for the potential of isoflavones to reduce risk of cognitive decline and dementia. So it's a pretty definitive statement. And isoflavones can be considered as a component of future dietary interventions for cognitive decline and dementia. I just want to take a little bit more detailed look at this meta-analysis because it's such a critically important contribution to the literature. One of the findings I want to point out is that it looks like isoflavones were more effective in younger postmenopausal women. So if isoflavones were consumed in women below the age of 60, so basically between the ages of 50 and 60, it looked like isoflavones were more efficacious. And that finding actually fits with what we know about other estrogen-like compounds. Also, although in general there was an improvement in cognitive function, when you look with more detail at the data, you see that the domain that was most improved was memory. So just to sum up things, although definitive conclusions cannot be made, recent data suggests soy exerts cognitive benefits in postmenopausal women and possibly men. Now let's move on to skin wrinkling, which unfortunately most of us are all too personally familiar with. but it's a natural phenomenon due to a variety of degenerative, environmental, genetic, and hormonal influences. There are absolutely some very intriguing preliminary clinical data suggesting that isoflavones improve skin health and specifically reduce wrinkles. Now, I became interested in this area of research in 2014 with the publication by Jenkins of a clinical study which found that a combination of isoflavones, omega-3 fatty acids, lycopene, vitamin C, and E, when consumed for 14 weeks, significantly reduced the depth of facial wrinkles. So let's take a brief look at this study. It was a very large study, 159 postmenopausal women, 14-week intervention, and the primary outcome was the change in the crow's feet wrinkle depth. The crow's feet refers to the wrinkles around the corner of the eye. In very abbreviated form, the results showed that there was a statistically significant decrease in wrinkles. The average decrease was about 10%. Now, the greater or the more wrinkles a woman had at baseline, the more likely she was to benefit, and the more likely the benefit was greater. And wrinkles were reduced because there was an increase in collagen synthesis. And that's a very important point. Collagen, as I'm sure most of you recognize, is the most abundant protein in the body. It forms a scaffold to provide strength and structure in many tissues, but especially in the skin. Unfortunately, with age, collagen synthesis decreases, and as a result, wrinkles can develop. Now, of course, one of the weaknesses to this study design is that the intervention consisted of a cocktail of bioactive ingredients, isoflavones, a carotenoid, antioxidants, vitamin C and E, and omega-3 fatty acids. So how do we really know that isoflavones contributed to the effects that we just saw, the reduction in wrinkles? Well, we have a pretty good idea that isoflavones were primarily responsible for this effect because unless you're deficient in these nutrients, they don't affect collagen synthesis. In contrast, isoflavones actually added to this mix specifically because of their effect on collagen. Also, when this research was presented at a scientific meeting several years ago, the investigators indicated that when isoflavones were removed from the preparation, the benefits were lost. Now, that hasn't been stated in a peer-reviewed journal, but it was a comment made at a scientific symposium. Here we have a study from 2018, daily intake of fermented soy milk as well as unfermented soy milk, the traditional way of making soy milk, improves skin condition via increased levels of isoflavone absorption. So let's take a look at this study. 8 weeks, 57 postmenopausal women. The women consumed either 200 milliliters per day of fermented soy milk or unfermented soy milk. Each of the soy milk provided about 40 milligrams of isoflavones. Efficacy was determined by a facial questionnaire, facial skin questionnaire, and by also taking a biopsy of the skin. Not surprisingly, during the 8 weeks from week 0 to week 8 that the soy milk was consumed, urinary isoflavone levels increased quite markedly. Upon discontinuation of the milk consumption, isoflavones returned to their baseline urinary values. Here we have the results of the facial skin questionnaire, and there are a lot of numbers here, so I'll just summarize for you. Basically, with only one small exception, there was an improvement in skin health as judged by the participants themselves, both in response to the unfermented soy milk and the fermented soy milk. When soy milk was discontinued, the values began to return to their baseline levels. Now, of course, this is a subjective determination. There was no actual placebo or control product used in this study. However, as I mentioned, there was also an objective determination of efficacy, and this was the biopsy of the skin taken from under the forearm. And here we see as the score increases, it means there was an improvement in skin health. And when you go from week 0 to week 8, both in response to conventional soy milk and fermented soy milk, there was a statistically significant improvement. So these results are extremely encouraging. Now, in total, there have actually been about 8 studies, the couple that I've shown, plus the several others. And collectively, these data suggest that isoflavones reduce wrinkles. All of these studies have some design limitations, perhaps small sample size, maybe a lack of a control group, but collectively they are very encouraging. And they were certainly encouraging enough for the United Soybean Board to fund a 2-year clinical trial to the tune of about $400,000. The primary endpoint is wrinkles, and the intervention will be an isoflavone-rich soy protein. So I'm very optimistic that this trial will provide sufficiently robust data, so we're going to be able to make some very definitive statements about the ability of soy to reduce wrinkles. And there's one other point that I want to emphasize about soy and skin health, and that has to do with an understanding of the mechanism how isoflavones may work. So how do isoflavones improve skin health? Well, of course, we don't know for certain, but we have a pretty decent understanding of at least the possibility of how they're working. And this is a point I made earlier in the presentation, that isoflavones preferentially bind to and activate estrogen receptor beta in comparison with estrogen receptor alpha. Now, some of you may already know this, but estrogen receptor alpha, the original estrogen receptor, was discovered in 1958, identified in 1958. Much more recently, 1996, estrogen receptor beta was identified. Now, estrogen binds with equal affinity to each of those receptors. In contrast, isoflavones prefer estrogen receptor beta. Now, why is that important? Why is it important, especially in relation to skin health? It's important in relation to skin health because estrogen receptor beta and not estrogen receptor alpha is the main mediator of estrogen action in the skin. So molecules that target estrogen receptor beta have a really good chance of improving skin health. And in fact, that's what this review stated almost exactly. Estrogen receptor beta is a novel therapeutic target for the prevention and treatment of photoaging. So I'm very optimistic about this area of research. Next, liver fat, just a few minutes, and then we'll get to the protein leverage hypothesis. Unfortunately, there's really an epidemic of liver fat. There are a number of conditions related to the accumulation of liver fat. You have fatty liver, then NASH, and even cirrhosis. The prevalence of non-alcoholic fatty liver disease is as high as 24% across the world. And that's because of the obesity epidemic that we're in the midst of. If you're obese, you're more likely to have a fatty liver. That cirrhosis can even increase risk for cancer, and a fatty liver can increase risk for diabetes. So it's a very serious condition. Now, there may be an impact on the type of fat on whether one develops fatty liver, not just whether one becomes obese. So here we have a study published in 2018 that found decreased intakes of saturated fat could be beneficial in reducing liver fat and the associated risk of diabetes. So let's take a quick look at this study. 38 overweight men and women, the diets were consumed for 3 weeks. This was an overfeeding study, so they actually consumed about 1,000 more calories each day than they needed for that 3-week period. One diet was high in saturated fat, one diet was low in saturated fat, high in unsaturated fat, primarily monounsaturated fat, and then a third diet was high in simple sugars. And here we have the results for the 38 overweight men and women, and we're looking at the percent increase in liver fat. Now, all 3 diets increased liver fat accumulation, which isn't surprising because it was an overfeeding study. But you can see that saturated fat increased liver fat accumulation by 55%, unsaturated fat by only 15%, and the difference between the 2 diets was statistically significant. Now, this unsaturated fat diet, as I indicated, was mostly monounsaturated fat. Here we have a study that compared saturated fat with polyunsaturated fat, and it found saturated fat markedly induces liver fat, whereas dietary polyunsaturated fat prevents liver fat accumulation. So we see even more robust results when you compare saturated fat with polyunsaturated fat. So this was an 8-week study, again, overweight or obese men and women. Overfeeding studies, the goal was a 3% weight gain over the 8-week period. The muffins were the vehicle by which the different types of fat were added. The 40 grams per day, so almost 400 calories of fat in the form of muffins. They were the high in polyunsaturated fat or high in saturated fat. Now, what's interesting here is in response to saturated fat, like in the previous study, you see a statistically significant increase. In contrast, in response to polyunsaturated fat, you not only don't see an increase, you actually see a small decrease. So the point here, like a previous point with cognition, is that if you're going to replace saturated fat in your diet with polyunsaturated fat, you're going to perhaps reduce your risk of developing liver fat. And as has already been pointed out, soybean oil, of course, is predominantly unsaturated fat and predominantly polyunsaturated fat. And then finally, just a couple of words about the protein leverage hypothesis. I've really become intrigued by this hypothesis over the past several months. This hypothesis was first proposed in 2005, so it's quite old, but over the past couple of years, there's been a lot of support published for this hypothesis. And briefly stated, the hypothesis maintains that because of the body's strong propensity to regulate the amount of protein eaten, humans are at risk of obesity when the proportion of protein in the diet falls as a result of the dilution in the food supply by calories derived from non-protein sources such as fats and carbohydrate. In other words, if you're not getting enough protein in your diet, you're going to continue to eat more calories, consume more calories in order to make sure that you're meeting your protein requirements. I bring up the protein leverage hypothesis to just illustrate and emphasize that soybeans are higher in protein than all of the other commonly consumed legumes, and these data are percent calories from protein. You can see soybeans are about 38% protein. Most of the other legumes are in the mid-20s. And not surprisingly, all of the traditional soy foods and foods made with the soy protein ingredients like isolated soy protein and soy protein concentrate are very high in protein. They get anywhere from 25 to 45% of their calories from protein. So in summary, isoflavones may improve cognition and skin health. The low saturated fat content of soy foods may help to prevent cognitive function decline. The high polyunsaturated fat content of soybeans may prevent liver fat accumulation, and the high protein content of soy foods may help to prevent obesity. So soy foods have a lot going for it. They have multiple components that may independently exert a number of health benefits, and collectively, I think it's very clear that soy foods warrant an important role in overall healthy diets. So I want to thank you very much for your attention, and I hope you enjoy the rest of the conference.